So you're ready to do some physical computing, which means working with electrical components like these and a computer. I've been teaching computing for many, many years, and physical computing has always been the most problematic thing. In the past, you need to buy interfaces, often buy special components, expensive applications, and these things will need upgrading. It all got very expensive, technical and difficult. And so physical computing has been a tricky area for teachers, even teachers with technical background knowledge. And for those with no sort of science or technical knowledge, it's been quite a kind of I suppose a scary area to get into. But things have changed a lot recently. And the biggest change, the most important one, was the microbit. So the microbit gives you a computer, albeit very small, to which it is very, very easy to connect electrical components. So when they designed the microbit, they realized that it was important to be able to do physical computing projects with it as part of the national curriculum, but also it's essential, if children are studying computer science or computing at school, they need to know how computers are used to control any sort of electrical equipment. So the microbit comes with this edge strip, which consists of sort of brass connections called pins, and the only ones you really need to worry about are the big 5, 0, 1 and 2, 3 volts and ground or earth or negative. So I'm going to show you how easy it is to connect an electrical component to a microbit. But for schools that don't have the components, you can go out and buy components already wired like this, but you can make them yourself. Now the edge strip is designed to connect in a number of ways. Some schools may have electrical components already wired up with these. They're called banana plugs actually, 5mm banana plugs, which will plug in. The hole is designed for these. Some schools may even have these spring connectors. The problem with these is if you push them right in, they're a bit loose. If you push them halfway in, then you get a good connection. But they're not brilliant. I think probably now the accepted way of connecting things to a microbit is using crocodile clips like these, and I'll come back to those in a minute. If you're going to make your own components to save a bit of money, components like these LEDs and these switches and buzzers and many, many other components now are very cheap. And if you buy in bulk, they're even cheaper. But I kind of, as a rule of thumb, go any component like this is going to cost me between 50p and £1. So if I'm creating a set of 20 LEDs for use with class work, then probably about £10 to make them myself, which is not that expensive. If you know a parent with a soldering iron, then you might be able to get them to make them up for you. Using soldering and shrink wrap, you can make really nice, neat components like this. But there are other ways of doing it. I'm going to show you my 2 preferred methods for schools that don't have a technical background or anybody who can do it for them, just to make some simple wired components. You don't need a lot of equipment. This is the only toolkit you need: a glue gun, a pair of scissors. This is the only specialist bit of equipment for stripping the insulation off the ends of your wires. You don't need to buy expensive insulating tape, just a roll of sellotape. Roll of sellotape will do. So I've bought my components. I've got my LED here, which I'm going to connect to wires. Excuse me. Now, I tend to cut my wires about 30 centimeters long. That's a good length. And so once I've cut my wires, I've got to get them connected to the component. So a little bit about the components. An LED has polarity. That means it's got to be connected the right way round. I can demonstrate that with my microbit here. If I put the LED at the top of the microbit power supply here. You can see the LED comes on. This is actually a flashing LED. If I turn it the other way around, it doesn't come on. And so that's what I mean by polarity. It has to be connected the right way around in the circuit, or the electricity doesn't flow. And to help you know which is the right way around, the LEDs are manufactured with a long leg and a short leg. The long leg is the positive one, and that's got to go to the positive side of the circuit. Now when I'm wiring them up, I use red and black wires. It's traditional to use red wires for the positive side of the component and black for the negative. Okay? This is stranded wire. When you buy wire, always buy stranded wire. That's sort of multi-strand. It's more flexible and easier to use, just nicer to use. So I've cut my two pieces of wire, red and black. I've got my component. How do I connect the wire to the component? First thing I've got to do is strip off the insulation, and that's where this tool comes in. If you push the wire through the hole and then push up with your thumbnail, it'll grip it, and when you pull, it'll strip off the insulation. And with stranded wire, I always then twist that to stop it splaying out. So I've got my negative wire and my positive wire. Now, two ways of connecting them. One of them is to use chock block, and this works quite nicely because you can take your components off, recycle them. It's not a permanent connection to the wires, and I'll show you how to do that quickly. This is where this tool comes useful. Chock block, you've probably seen these before. They're just a series of connections made by tightening a little bolt in there. So if I want to connect my LED to these two wires, first thing to do is to loosen the screws in my chock block so that I can get the wire in, and then I can push. I'm going to put my positive on the left and my negative on the right. It doesn't matter if you push them a bit further than midpoint. Okay, so now I can connect that by tightening the screws. Don't over tighten them. As long as it's gripping the component, it's tight enough. Okay, now you can even teach the children how to do this, and they can do it themselves. So I've got my LED connected to the chock block, and then the other end I connect my wire. So what I often do actually is just fold these over to get a slightly thicker, chunkier wire to connect. Again, loosen the screws. These wire strippers have a handy little screwdriver end which is small enough to get into the chock block. So loosen the screws, and then I've got my positive on the left, so that goes in there, and my negative, again I'm going to fold it over like that. Gives me a little bit more to grip with. That goes in there, and then tighten up. Now these are great for kind of prototyping and doing experiments and that sort of thing. They also work okay when they're in children's models, if children are making models that need lights, so fairground rides or traffic lights or lighthouses, that sort of thing. They're a bit chunky, but they work fine. There is a danger of short circuit if these two wires touch, so that's something you need to watch. Now if you want to have components you can easily hand out and use again and again and again, there's another way of connecting your components to the wires, and this is one that works very well and is reliable. And you can, once you've done this, you then hand them out again and again, and you won't have to fiddle around with chock block. All you need is your glue gun, your wire stripper and I'll show you how it's done. So I'm just going to bring this mat over here now. The scissors, by the way, are just for cutting the wire. So if you want to cut off lengths of wire, you don't need pliers or anything like that. A pair of scissors, snip through it easily like that. Okay, so I've got my 2 wires cut to length and the insulation removed. How do I connect them to my LED? Well, first thing to do is splay the legs out a little bit. These will break off if you keep bending them backwards and forwards. Now, I'm just going to cross them over like that and twist them together. And so, I make a sort of a join like that. And then, to tidy it up, just bend that back along the wire. And then on the shorter leg, do the same on my black wire. Twist them together. Okay. And fold that back. And what I could do before I do anything permanent is just test that. So I'm just going to strip the insulation off the other end, and I want to make sure that everything is working. So I can get my power supply from my microbit, push the wires into the power supply and test. I don't know whether you can see that, but my LED is working. Let's try and get my hands out of the way. So my microbit power supply becomes a good test. I could just put them on a battery, but there's the LED flashing. So that's working okay. So to make this a bit more permanent, because if you hand these out to children, the wires are just going to fall off. To make these a bit more permanent, just going to tidy it up a bit. I just use a glue gun. And the glue gun serves a number of purposes. It makes this join stronger, so that it's less likely to get pulled off. So I'm just having them close together, but not too close together, because the other thing the glue gun will do is it will prevent short circuit. Okay, if the 2 legs of the component touch, the current will take a short circuit, won't go through the component, could damage the microbit, and certainly the circuit won't work. Okay, so you can see how I've got that lined up. Just put some glue here. I'm being quite generous with it because I want it to cover the wires. I also put glue right up against the component because that just strengthens the part where the legs join the component. The weak part actually, and these wires do break off from time to time, is where the legs join the LED, and if that bends backwards and forwards, the legs eventually break off. Now, this is not the neatest, tidiest way of doing it, but it will make a secure connection and it will make a short circuit proof connection. It will prevent children spiking themselves on the end of thin wires. So it does work. Now if I just add a bit more glue on the other side, make sure that there's no way that the 2 legs can get pushed together, and then as that cools and sets, you'll have a pretty robust connection. You might want to come back and add a bit more glue to it later. So when you're making, or when the children are making models, all they need to see actually is the end of the LED, the bit that lights up. So they'll probably make holes in their models, push that through, and all this bit will be hidden behind the model out of sight, hopefully. Okay, so I think, that's probably good enough. When that hardens up a bit, you'll see how strong it is. You can always add some more glue later if you think it's not quite strong enough. Okay, so I've now got my wired component. How do I connect this to the microbit? Well, let's say for the project that I'm doing, I want to connect the microbit to pin 0 to the positive side of my component and ground or earth to the negative side of my component. Now, I strongly recommend that you do it using crocodile clips. You could just poke it through and wire it round if you wanted a quick temporary test. But crocodile clips are the best way of doing this. When I hand them out in bunches of 5. That's more than enough. You're only using 5 holes on the edge strip here. I tell the children to keep them cable tied together. Much easier to hand them out like this, and more importantly to make sure you've collected them all in at the end. So the colours are not that important really, but it does help you to know which wire is connected to which. So if I'm connecting this LED to this microbit, because it's got polarity and a red and black wire, I'm going to use the red and black leads, crocodile clip leads. Now the stranded wire tends to splay out like this. Again, if you've got somebody who can use a soldering iron, you can put solder along the ends of the strands and that will hold them together, but I'm just going to twist them together. Okay, so the positive wire on the LED needs to go to pin 0, so red crocodile clip on here, and I'm just going to fold that over, and black crocodile clip on here. Now the thing to watch, and that's one of the reasons why I fold that over, is short circuit. I strongly recommend you use insulated crocodile clips like this. If they touch, generally that will prevent short circuit, but the ends can still touch like that. Short circuit, not good for the microbits, and your circuit won't work. Now, as an extra precaution, I recommend you just have some sellotape handy. It's better if this is in a sellotape dispenser, because it's quicker and easier to use. And you just get the children to wrap, it just needs to be a short length of sellotape over the ends of the crocodile clip. So you don't need to buy expensive insulating tape. Sellotape will do, just a few centimeters length, and just very loosely put it over the end of the crocodile clip like that. And now that will prevent short circuit. Now the connection the other end is to take the 2 leads that we've connected to our component, and the red goes to 0 and the black goes to ground. Now often when you see videos you'll see people connecting like this, or pictures, but this is not a good connection. As the children move things around, those tend to come loose and fall off. The best way to do it by far is to open the jaws of the crocodile clip, push one jaw through the hole and connect them at 90 degrees to the microbit. That's a much more secure connection, and also the crocodile clips won't slide along the edge strip and cause short circuits. So we've now got our component connected to our microbit, and we're ready to create some scripts to control it. You can see now that it's hardened up. That's pretty secure, and that will last quite a long time as long as children are reasonably careful with it. And so that whole thing probably cost you less than 50 pence. You can buy and wire up switches like this as input devices, but the children can have good fun making their own. I mean, a switch is just a gap in a circuit that is closed, and you can see here a switch that was made by some children using a couple of these, I don't know what you call them now, and a paper clip, and when you touch that contact the current can flow. Burglar alarms based on pressure pads are easily made. So here's one. It's a bit of cardboard with a hole cut in it, and on here we've got some aluminium foil. You can use cooking foil there and there, with a wire sellotaped to the corner and a wire sellotaped to the corner, making sure the sellotape doesn't go across the middle of the foil. And when that's folded over, the switch is closed when pressure is applied to the top of the piece of card. What that does is it pushes the 2 bits of aluminium together through the hole and completes the circuit. So yeah, get the children to make their own switches. So great fun can be had with physical computing. It is worth the effort, and it also does mean that you're completing an important part of the computing programs of study. So have fun with that, and good luck.